Now then, in the workshop again. It's fairly breezy out there, so we can't be doing any filming because of wind noise. We picked up 3 of these a while ago. A friend of mine brought them over, and they were out of a big, quite old technology 48 volt inverter charger system. And this, it seems to me, is probably a switch mode power supply 48 volts DC. So I'll just bring you into the label, and then we're going to talk about things, because there's a few bits that need investigating. So there we go, 100 to 240 in, 48 volts out, 32 amps. Yeah, so the interesting bits are, there's these 2 ginormous buzz bars here, yeah, but also control wires. Now, what I want to know is, will this work without them? We can't focus. Right, let's get in closer. Okay, hopefully this will be better. Yeah, so will this work if these data cables are not connected? First of all, you see on that big buzz bar, that's volts plus, and I'm assuming somewhere it'll say volts negative on the other one. So I'm not sure, but there is an interesting thing there. Volts adjust. So that'll be quite interesting. Can't quite see what it says there. Right, it says CN1, CN2, CN3, and then it goes on. Well, there's a little LED there. So, do you know what? You know what I'm about to say? There's only one way to find out what's going on, and that is just plug her in. So that's what we're going to do. Plug it in and see what volts come out of this. That's the way to start. So let's just get that set up. So we've got the quick connect on the AC in, and these data cables, I've just made sure that the ends are not shorted together. So let's go for it. Will it be smoke, or will it be something useful? Contact. Well, there's a fan running, and we're on DC 200. That's the positive, that's the negative. Hopefully you'll be able to see this. Yeah, the LED is on, and we're getting 61.3. Interesting. That's quite a high equalizing charge, isn't it? But we can adjust that, so at least it works, which is great. So I think the thing to do now is switch it off. And I think we could probably do with just having the covers off, and just to see what it's like inside for interest, and maybe to clean it out, because if it's been used for a long time there might be a lot of muck in there, and if we got cooling we want it to work well. Rather like a laptop, you should always blow them out or use a vacuum cleaner on the ports to clean the muck out. So let's just undo that. It is switched off, and where are we going to start? There's some screws there and along there, but then there's some weird bolt type things there, which means that things are bolted to it. I don't want to damage this, but I think I can safely remove these wires. I'm assuming that's a socket of some form. Doesn't seem to want to come out. Leave that one with me. I'll see if there's a catch or something. Well, those data cables did just come out, but it just took a little bit of mild levering. So that's the last screw of this end plate. Okay, oh, that's interesting. Yep, it looks quite black in there. Let's just zoom down a bit. Now I know that this was in the same sort of shed as a diesel generator, so I'm thinking that's probably diesel carbon. If you look in that corner there, that screw is connected to that case. So this here is connected to a hexagon on the outside. So clearly this board is connected to here, and this board is clearly connected to there. Now, I don't know whether it splits down the middle or whether this board and that board are connected together. But first of all, I think we could do with just removing that. So that's the fan out of the way. And you can, on these fans, just carefully remove the sticker and put a very small drop, 1 micro drop of oil on the fan spindle, and then put the sticker back. Stops them rattling. So let's just turn this around and see if we can take the other end off. Well, it looks like the cover comes off, so we'd have to remove these. So this plastic is retained and the cover sits around it. Oh. So let's just take the wires off. We've got AC live and AC neutral and earth, so they are marked. And remove the bolts. Whoever took this out took the care to put the bolts back in, which is quite nice. So let's just see. We've got 1 screw there. We've got 1 screw. Yeah. This really might be quite useful. And I think the charger that this came out of was a 3-stage charger. So it could have been that the differing chargers, the 3 of them, had different voltage settings. Well, it's not too bad, but it looks a bit horrible and grimy. Does it? Well, if you look here, this is one of those really difficult things. We've got a bolt there and a hexagon on the outside, but that there, that doesn't go through that. That is cut around that. So we come round here and it's the same there. So I'm thinking I'm just going to undo a line of screws along there and a line of screws along there and just see what happens. And how are we going to test this on a load? Well, we have a 48-volt battery bank, or, oh, something's happening. Diesel fumes, I think. So I'm just going to go and blow this lot out with the airline. Because if there was a fault in this lot, I won't be able to see it because it's all black. Right, I'll get back to you. So it comes apart and there's a socket there. And there's a socket there. So if I choose to, I can actually have these two halves apart, which might be a good idea. That's that one out. And this other one, can't quite see how it comes apart. There might be a look, there we are. Great, it's in two halves. Brilliant. Right, I'm just going to clean that lot up. So there are the two sockets just down there. You know what? It's like dig in there, but because it works, or I think it works, I was rather tentative. Right, get back to you soon. Well, a fair bit of muck came out of that. So let's just put these sockets back together, if we can. They only go in one way, which is lucky. That's that one. And that has only got 2 pins. Okay, and then it goes like that. So I'm just going to put those screws and put the end caps on, and I'll get back to you shortly. So whilst we're here, I might as well do a bit of maintenance on this fan. Gently, very gently, pull that back like that, turn it round, and the merest drop of oil in there, and that'll do, and then glue that back in. There we go. And that should run a bit quieter or smoother or something. Yep. It's a bit mucky, but it's sort of stuck to the surface. But it's not like a computer fan where you've just got shed loads of hairy stuff hanging around. Bits of cat hair and whatnot, and carpet fluff. So this then needs to plug into which way round does it go? It does go round that way. There, good. With those fiddling little pins, you've got to be very careful to not bend them. So we'll stick that back together, and the next point of call, as it is to attach it to 48 volts worth of batteries and see what happens. I think I'm going to use 4 12-volt car batteries for the primary reason that the main batteries at the moment are up at 57 volts. So I would like to try this on something that has closer to 48 volts. That way we will see what the current is on full load. There we go. Did I tighten those up? I did. Right, let's crack on. So now's the time to test things. We have got 4 12-volt batteries, reasonable sized ones, about 80 amp hours each. That's storage, not cranking. They're all in series, so that's 50 odd volts there, and we're about to wire things up. So there's the charger, and I've got the polarity right. So earlier on I'd got it wrong, but that's just because there was a load of muck on it and I couldn't see properly. So there we go. So the negative is that lower one. So I'll just show you battery voltage. We know output voltage from this charger is 61.3 volts. So let's just check things out. Where's the batteries? Right, let's just... So hopefully you can see that. Probably not. That might be a bit better. Negative. Where's the positive? There we are, 51.7 volts. Yep. So it looks like most of these batteries are about 13 volts. Right, let's set up and do the test. So there was quite a spark when I connected the batteries up, so obviously it's got capacitors in here. Now we've got the clamp meter showing DC amps. Let's just zero it out. Okay, I think we're there. I think what I'll do is I'll zoom down on this meter. There we go. Right, contact and the fan will run. Well, that's interesting. Obviously we've got the meter the wrong way round. But because of that little negative sign there, Okay, so let's just, there we go. And battery volts are, hopefully you can see that, you probably can't. So that's quite interesting. I mean, obviously these 12 volt batteries, because I'm looking after them, they're reasonably high volt. Yeah, we're on 61 volts. There you go. So if those batteries were flat, I mean, it started off with about 29 amps, I think, very, very briefly. Yeah. So do you think we've got to do the standard, put a load across it like we did last time, pull the voltage down and then see what happens? I think we should. Right, let me get that set up. That's grand. Right, I've got a piece of nichrome wire there. It's quite a heavy duty one, and it's drawing 12.5 amps. So that's okay. So that's a draw. So let's just see what the battery voltage is. Where are we going to sit the meter so you could see it? There we go, and it's on. And battery voltage now is, let's just get this right, from there to there. Come on, let's get a proper reading. Where's the post? 48.3. Can you see that? Good enough. So that 12 amps is drawing that voltage down, and if we wanted it to draw more, we could just move one of the clamps further along to shorten the length. I can smell it, it's just warming up. Let's just see what happens now with the charger. So let's just move on and move to the charger. Right, I think we're all there. Contact. There you go. 31 amps. Yeah. Splendid. So we pulled the battery voltage down with a nichrome resistance wire, and as you can see, I think that was drawing what, 12.5 amps, something like that. And so this charger is the better of it, because the voltage is obviously going up and the current is going down. So let's just see if somehow, let's just zoom out a bit. Yeah, and the voltage is, well, it is 61, but the current is 22.9, 22.7. Interesting. That's a bit weird. It's very weird that that voltage is, got it the wrong way round, shouldn't make any difference. Yeah, 61.1. I expected that voltage to be slightly lower because the batteries would pull the voltage down, therefore draw the current. And I'm just going to disconnect the Nichrome dump load with a big spark. And there you go. Current's gone down. Brilliant. But I suspect the voltage is still the same, 61, so it's a constant voltage. Or so it seems. I might be wrong. I might be misinterpreting this. Can we see the voltmeter? We can. Yeah, 61.1. So there you go. Interesting. I'm going to give these a good road test this winter. When you get like November, you get a few days of mist and no sun and no wind and no generation hardly, and then you get another day where it's really sort of, or it brightens up a bit, shall we say. I wouldn't really say that it's giving full beans. Then during the day, because the grid ties, or the grid solar grid systems will be putting loads of power out, then we can run one of these back into the batteries. So it's still sort of green, sustainable, low carbon, no input from the grid, and these look like they might very well do the job. And of course they're self-regulating, as you've seen, which is, I mean, I'm not quite sure because it's got constant voltage output. Bit strange. I might be misinterpreting it, but that's what it seems like. So it's a variable current, constant voltage. Doesn't seem right to me, but obviously that's what they are. Anyway, comments, discussion. I'd like to hear what you think about this sort of thing. Switch mode. Are they more efficient than a standard big transformer and a rectifier? Are they more reliable? Are they more controllable? Interesting. Hopefully we'll get a discussion going, and beyond that there'll be another video up fairly soon, and I will catch up with you then. Cheers for now.